Okay, so this is a key to worksheet section 2.2 and part 2. Alright, so in the first 4 problems, they want you to evaluate each piecewise function. So notice that each function is made up of 2 equations. So, and remember, these are called your restricted domains. And so you want to evaluate these functions at these numbers. Okay? Alright, so remember in part 1, you're told that this function is 3x minus 4 if x is less than 3, and then 7x plus 1 if x is greater than or equal to 3. Okay? So in part A, it says, remember, fx is the same thing as y value. What is the y value? What this means is, I'm just going to do it for this one. What is the y value? What is y when x equals 0? That's what you're asking. Okay, so first of all, you got to determine which of these, in which domain is x equals 0 located. So, for example, is 0 greater than or equal to 3? The answer is no. Is 0 less than 3? The answer is yes. So this is a function you're going to use. So for part A, let me go ahead and actually do this on here. So in part A, 1A, to find f of 0, you're going to use f of x equals 3x minus 4. Okay, because that's the one where 0 is located. 0 is less than 3. Okay, so to find f of 0, you're going to say 3 times 0 minus 4. So that's 0 minus 4, which is a negative 4. So that's f of 0. Okay, to find f of 3, okay, the b part, to find f of 3, remember this says find y when x equals 3. So we have to use the one in which the x value of 3 is located. So here's the question, is 3 less than 3? The answer is no, 3 is not less than 3. But is 3 bigger than or equal to 3, greater than or equal to 3? The answer is yes. 3 equals 3, so this is the one we're going to use now. So for f of 3, we're going to use this function, f of x equals 7x plus 1, because that's the one where x equals 3 is located. X equals 3 is located in this domain. And so, where we see the variable x, we're going to plug in 3. We're going to substitute 3. So I get 7 times 3 plus 1, so that's 21 plus 1, which is 22. So f of 3 equals 22. Okay, f of 5. So again, the same idea. So f of 5 means find y when x equals 5. Okay, so we have to first of all determine which of these functions, which function here I'm going to use, and it depends on where 5 is located. So is 5 less than 3? The answer is no. Is 5 bigger than or equal to 3? The answer is yes. So again, this is the one I'm going to use. So I'm going to use f of x equals 7x plus 1. So to find f of 5, where we see the variable x, I'm going to plug in 5. I'm going to substitute 5. So I get 7 times 5 plus 1, so that's 35 plus 1, which is 36. So f of 5 is 36. Okay, so that takes care of number 1. Okay, number 2, same idea. And number 2. So number 2, again, this says that you're gonna that g of x will equal x minus 1 if the values in your domain are bigger than 0. And then it's going to equal negative x if the values in your domain is less than or equal to 0. So for part A, I want to find g of 0. So again, what that means is that find y when x equals 0. So let's go over here and see which of these domains is x equals 0. So obviously it's not this one because 0 is not bigger than 0. But 0 is less than or equal to 0. It's actually equal to 0. So that's what you're going to use right here. So we're going to use g of x equals negative x. So to find g of 0, you're going to, where we see the variable x, you're going to plug in 0. So I get the opposite of 0, which is still 0. So g of 0 is 0. So 0 goes here. To find g of negative 2, okay, g of negative 2, b, g of negative 2. So again, find y when x equal negative 2. So I got to determine which one of these functions I must use. So remember, I'm trying to determine where negative 2 is located. So obviously negative 2 is not bigger than 0. So it's here. So negative 2 is less than or equal to 0. So I'm going to use this. So I'm going to use g of x equal negative x. So to find g of negative 2, wherever I see the variable x, I'm going to plug in negative 2. But be careful, you still have that negative out here. So when you read this, I'm going to read it as this. This has become the opposite of x, and x is negative 2. So the opposite of negative 2 is a positive 2. So g of negative 2 is a positive 2. To find g of 4, so again, this time you're told x is 4, so I got to find the y value. So I got to determine which one of these is 4 located. So is 4 greater than 0? The answer is yes. I'm going to use this one. So I'm going to use g of x equal x minus 1. And so to find g of 4, where we see the variable x, I'm going to substitute g minus 1. I'm sorry, I'm substitute 4. So I get 4 minus 1, which is 3. So g of 4 is 3. Okay, now let's do this one. All right, 3. Okay, so here, notice that this says not equal to, this says equal to. Okay, so as we go through this, we'll discuss what that means. All right, so in letter A, you want to find f of negative 2. So again, this means find y when x equal negative 2. Okay, so let's kind of understand how to read this. So this says, let's start with this one. This says that I'm going to use this function if x equals 2. That's what that says. So if x is 2, that's what I'm going to use. This says I'm going to use this function if I use a number not equal to 2. So if the x value is not equal to 2, I use this. If it's equal to 2, I use this. Notice it's not greater than or equal to, it's not less than or anything like that. It's strictly not equal or equal. Okay? So here, this says find y when x is negative 2. So I got to determine, see, I want x to be negative 2. So the question is, it's always easy to use this one, to talk about this first. Do I use this one? Is my function going to be x plus 5? Well, it says that I only use this if x equals 2. Well, is that what x is? Is x equal to 2? No, x is equal to negative 2. So I got to use this one. So that's the one where x is not equal to. So where you see the variable x, I'm going to plug in negative 2 here. So I must use f of x equals x squared minus 4 over x plus 2. That's the one I must use. I'm sorry, x minus 2. That's the one I must use. Okay? All right, so let's find f of negative 2. So again, where we see the variable x, and I see it twice, I'm going to plug in, I'm going to substitute negative 2. Again, make sure you put parentheses there over here. So that's negative 2, which must be squared, so put that in parentheses, minus 4 over negative 2, subtract 2. So negative 2 squared is 4, so 4 minus 4 over a negative 4, so that's 0 over negative 4, which is just 0. You must say 0. Don't say 0 and negative 4, because that would imply you really don't know that 0 divided by a non-zero number is 0. So this is 0. Okay, let's talk about f of 6. So B, to find f of 6, same idea. So this says find y when x equals 6. So again, let's talk about this. Do I use this one? No, I only use this if x is 2. So this is what I must use, because this is the one that says if your x value is not equal to 2, then use this. I got to use this. So we must use f of x equal, again, this function, the same function. All right, so let's find f of 6. So where we see the variable x, I'm going to plug in 6. So I get, in my numerator, I get 6 squared minus 4. In my denominator, I get 6 minus 2. So 6 squared is 36. So 36 minus 4 over 4. So that's 32 over 4, which is just 8. So f of 6 is 8. So my y value is 8 when x is 6. All right, now let's find f of 2. C, f of 2. So again, this says find y when x equal 2. All right, so again, do I use this one? Yes, that's the one I use because now x is 2, so I must use this one. So I'm going to use f of x equal x plus 5. So to find f of 2, where we see the variable x, I'm going to substitute 2. So I get 2 plus 5, which is 7. So f of 2 is 7. So what we found was that when x is 2, my y value is 7. All right, takes care of 3. All right, 4, this one says h of x is going to equal x squared if my x values are less than or equal to 1. If my x values are greater than 1, I'm going to say it's equal to negative 2. Okay, so let's look at part A. So let's find h of 0. H of 0. So again, this says find y when x equals 0. So let's see where x is equal to 0. So is 0 less than or equal to 1? So is it this one? The answer is yes. Because it's not here, because 0 is not bigger than 1. 0 is less than or equal to 1. So this is what I'm going to use. So I'm going to use h of x equal x squared. So where we see the variable x, I'm going to plug in 0. So I get 0 squared, which is just 0. So h of 0 is 0. Okay, let's find h of negative 5. So b, h of negative 5. So to find h of negative 5, so let's see which one we're going to use. So let's look at the first one. Is negative 5 less than or equal to 1? The answer is yes. So that's what I'm going to use. So I'm going to use h of x equal x squared. So to find h of negative 5, where we see the variable x, we'll plug in negative 5. So I get negative 5 squared, which is 25, a positive 25. So that goes here. So when x is negative 5, my y value is 25. Let's find h of 5. Okay, so C, h of 5. All right, so let's see which one I use. So again, is 5 less than or equal to 1? The answer is no. Is 5 greater than 1? The answer is yes. Now, look what this says. So I'm going to use h of x equals negative 2. Now remember what that means. That means that h of 5, so where we see the variable x, I plug in 5. Now the others were easy because there was a variable in your function. Here there's not a variable, but we've talked about this before. Remember this says that y, h of x, remember is y. So this says that y must equal negative 2. Y always equals negative 2. That's what that says. Remember that says y always equals negative 2. So no matter what x is. Alright, so remember we graphed horizontal and vertical lines? That idea. So no matter what x is, if x is 5, that says y has to equal negative 2. Alright, and in D the same thing. So look at D. H of 1. Oops, no, that's not the same thing. Alright, so let's do this one. So C, h of 5 is negative 2. So that's this. So again, if I had, like, let's say this was h of 7. H of 7. So is 7 bigger than 1? The answer is yes. So my y value has to equal negative 2. That's all that's saying. H of 10 is going to be negative 2. So notice that no matter what my x value is, as long as it's bigger than 1, my y values are always the same. X of 1.7, my y value is negative 2. That's all that's saying. Over here, D. Let's talk about D. So this says what is find y when x equal 1. So when x is 1, let's see if I use this one. Is 1 less than or equal to 1? The answer is yes. So I must use this one. So I'm going to use x squared. So use h of x equal x squared. So to find h of 1, where we see the variable x, we'll plug in 1. So I get 1 squared, which is just 1. Alright, so that's the first page of this. Now let's look at the second page. The second page talks about graphing piecewise functions. So now we're graphing piecewise functions. All right, so to graph these, we're going to do each one individually. Okay, so first we're going to graph f of x equal x plus 2. And remember, I'm going to graph this only if x is less than 2. So keep that in mind, less than or equal to 2. So when I graph this, and remember these are all going to be linear. So you just remember these are going to be raised now. These can be raised. So remember though, whenever you graph these, you must use these points. You must use them. So that must be the first x coordinate you're going to use. Same thing here. The first x I'm going to use will be -1. All right, so you must use those. All right, use. Okay. So in a t-table, you've got to use 2 first. So put 2 first. Okay, so if x is 2, I get y, f of x remembers y, so y equals x, which I'm saying is 2, plus 2, which is 4. Okay, now remember, this is an equal sign, so when I apply that point, this is going to be a closed circle. Closed circle. And I'll give you one more number that's less than or equal to 2, so let's say 0. If x is 0, I get y equals 0 plus 2, which is 2. All right, so let's graph this. So 2, 4 is here. It's closed circle now. And then 0, 2 is here. Okay? So then remember these are raised, so don't make the mistake and draw a line like this. That's not true. Okay? So this graph, it starts when x is 2. This is your starting point. This is your end point. Think of this as an end point of array. End point of array. Okay? So they're not strictly lines with 2 arrows because your domain's restricted. See, this domain here is not all real numbers. It's only numbers that are less than or equal to 2. So these domains are restricted. So remember, array has an end point. So when you graph the array, you start at the end point. You start at the end point. So you must start here and then connect at other point. Okay, so it's going to look like this, and do the best you can, but it'll look like this. There's one of your that's the array, that's the graph for that first function. For the second one, do the same thing. Okay, so now let's graph f of x equal -2. So remember what that means again. That's just like the previous problem we did right here. Okay, right here. So that says that y, remember this says that y always equals -2. Okay, so let's do a t-table. Let's talk about this. So again, I've got to start with -2. I got to start with 2. So I got to start with 2. So when x is 2, this says my y value is -2. So give me another number that's bigger than 2. So remember, we've got to use this if x is greater than 2. So give me another number that's bigger than 2. Let's say 4. If x is 4, this says my y value has to be -2. Now let's talk about open or close. So this is going to be my endpoint. This is going to be your endpoint. So remember, you must use those, and those are going to be your endpoints that you're going to, when you graph these points, those are going to be your endpoints. But it's going to be open, and it's going to be an open circle because there's no equal sign here. This is just greater than. So when I plot 2, -2 now, so think about what that means. When I plot 2, -2, right here, I'm going to put an open circle. And when for -2 is going to be on the graph, so that would be a closed dot here. And then all you do is connect them like this. So there's your graph. Okay? There's your graph. So notice those are raised though. Those are raised. So make sure you're graphing these raised. These are all linear functions. So when you are restricting the domain like we are here, those are going to be raised. Some will have a closed circle, some endpoints will be an open circle. All right, let's talk about this. And again, notice that these are linear functions. So in a graph, f of x equals 3x plus 1, just remember that I'm going to use that if x is less than -1. So the values for x must be less than -1, and I must use -1. That's going to be my endpoint. So your endpoint occurs when x is this number. But it's going to be open because there's no equal sign, so keep that in mind also. So it's an endpoint that's open. So when x is -1, where we see the variable x, I'm going to plug in -1. So you got 3 times -1 plus 1. So that's -3 plus 1, which is -2. So I'll plot the point -1, -2. So -1, -2 is here. It's an open circle, kind of like this. All right, I need one more point. So give me another number that's less than -1. So let's say -3. If x is -3, I get y equals 3 times -3 plus 1. So that's -9 plus 1, which is -8. So I'll plot the point 3, -8. And 3, -8 is, looks like it's here. Okay? And so I connect those. Remember, that's a ray. These are rays. This is your starting point right here. This is your end point. You connect them with an arrow. Don't extend it. That's an end point. It's a ray, so you must use an end point. All right, so align these and just draw your graph, and there's your ray. Okay? Now let's do the other one. So now we're going to graph f of x equal x minus 3, and this time if x is greater than or equal to -1. So again, in my t-table, I must use that x value right here because that's going to be my end point. So there's going to be an end point. Now the question is it open or closed? The answer is closed because of the equal sign. So it'll be closed. This one's open, the other one's going to be closed. So when x is -1, where we see the variable x, I plug in -1. So I get y equals -1 minus 3, so that's -4. So I get -1, -4, which is here, so that's closed. So close that circle. Give me another number for x that's greater than or equal to -1, so let's say 0. If x is 0, I get y equals 0 minus 3, which is a -3. So I get 0, -3, which is here. And so remember, it's a array, so this is your starting point right here. This is your end point, so you connect them going this way. All right, so when I connect them, do the best you can, I get something that looks like this. All right, so there's your graph. Okay, so go back and review all that we discussed about, because remember, you got to use these numbers for x's, and those are going to be your endpoints. These are going to be your endpoints. So endpoint open, endpoint closed, and so on. Okay, this is how it looks. Okay, so that's going to take care of the key to worksheet 2.2, part 2.